That skill presents Factorising Trinomials. A trinomial is an algebraic expression with three terms in it that are separated by plus or minus in between them. A very important type of a trinomial is a quadratic expression in which you have a term containing the square or the second part of the variable, another term that has got the first part of the variable, and then a constant term. And you may or may not have numerical coefficients multiplied with the variables, and if you don't see anything there, you can assume the coefficient to be 1. A couple of examples of trinomials. X squared minus x minus 6 is a trinomial. It's got a term in x squared, a term in x, and a constant term which is negative 6. 2p squared plus 7p minus 4 is another trinomial where you have a term in p squared, the square of the variable, the coefficient is 2 or a positive 2. Then you have a term in p, the first part of the variable, whose coefficient is positive 7, and the constant term is negative 4. When you want to factorize a trinomial, your first job is to take out the common factor between the three terms, if there is any. If there is no common factor between all three terms, which means the common factor is 1, you can straight away start factoring the trinomial. And to be able to do that, our first job is to break down the middle term in the quadratic expression into two pieces, so that when you add them up algebraically, you get the middle term, and when you multiply the two pieces, you get the product of the first and the third terms. When we have an algebraic expression, we usually write that down in descending powers of the variable. So you have the highest power of the variable on the far left, followed by the next highest power, and so on until you reach the constant term. So when I say middle term, I essentially mean the term that has got the first power of the variable in a quadratic expression. When I say the first term, I mean the square of the variable, the term that contains the square of the variable. And then when I say the third term in the expression, I mean the constant term in which there is no variable at all. Time for us to look at some examples to understand this process better. I'm actually going to take the same examples I wrote down on the previous page. So the first one is x squared minus x minus 6. Let me write that down. X squared minus x minus 6. We want to factorize this. Obviously, the greatest common factor between these three is 1. And obviously, there's no point writing a 1 outside a parentheses and just writing the same thing down inside. So what we are going to do is we are going to straight away try and break this middle term down into two pieces that add up to negative x or negative 1x. If you do not see a coefficient or a constant being multiplied with a variable, it means there's a 1. So let's get this. We need two numbers. We need two numbers that add up to give us negative 1. Something plus something is negative 1. And then that multiply, like I said, they have to multiply something times something, the same two numbers, multiply to give you the product of the first and the last term. Now you could just ignore the variable part of the first term, and you could just say that, okay, the product is going to be the coefficient over here, which is 1 obviously, 1 times negative 6, which is negative 6. Now when is the product of two numbers negative? When one is a positive and the other one is a negative. So we cannot have two negatives or two positives here, so I'm going to straight away write a negative and a positive here. Now because they add up to negative 1, the negative has to be more than the positive. And the only way out is if we have a negative 3 and a positive 2. It gives negative 6 as the product. And then if you do a negative 3 plus a positive 2, you end up getting negative 1. That's exactly what we were looking for. So the split is going to be negative 3x and a positive 2x. And then we have a x squared as the first term. No change on that, and the constant term is minus 6 or a negative 6. And the idea now is to pair these up and factorize them. So this is going to be equal to, if you try and factorize these two, the common factor between x squared and 3x is x. So you take a x out, what's left is a x. X times x is x squared, minus x times 3 is 3x, plus common factor between 2x and 6 is 2. If you take a 2 out of a 2x, you're left with a x. And then if you need a 6, this minus comes down here. Or let's say we need a negative 6, whichever way you want to look at it. 2 times negative 3 is negative 6. Now if you look at this term and this term, there's a common factor between these two. And the common factor is x minus 3. If you cannot see that, let's say that x minus 3 is a or something. So this is like saying x multiplied with a, where a is x minus 3, plus 2 multiplied with a again. And as you can probably see now, a is the common factor between these two. So we are going to take out the a and write an x plus 2 inside. Now what's a? A is nothing but x minus 3. So this is going to be x minus 3, replace that back, times x plus 2. This is the factored form of x squared minus x minus 6. Let's try the other one. We had 2p squared plus 7p minus 4. 2p squared plus 7p minus 4. Once again, the idea is to break this down, to split this middle term into two pieces, so that we have two numbers. We need two numbers. I'm going to write that over here. Something plus something is going to be equal to a positive 7, and then that same thing times the other thing, the same two things, multiply to give us 2 times negative 4, which is negative 8. And once again, because the product is negative, we cannot have both positives. Even though they add up to a positive, we cannot have both positives. One has to be a negative and the other one is a positive. Now if they add up to a positive, a negative and a positive adding up to a positive, the numerical value of the positive has to be more than the negative. So here we are looking for a plus something and a minus something, and the plus is more than the minus in terms of its numerical value. And the only way this could happen is if you have a positive 8 and a negative 1. Positive 8 times negative 1 is negative 8. And then if you have a positive 8 plus a negative 1, obviously you get a positive 7. Let me just draw a line here. So we have a 8p minus 1p or p minus 4, and obviously we have a 2p square right in the front of the expression. Time for us to pair them up and factor. Common factor between 2p square and 8p is 2p. Open parentheses, close parentheses. If you take a 2p out, you are left with a p, plus if you take a 2p out from this, you're left with a 4. Now if you look at this negative p and negative 4, there doesn't seem to be any common factor between them. And if there is no common factor, and we have to factorize that, the common factor is obviously 1 or a negative 1. Let's put a negative 1 here because both terms are negative. And not only that, we also need a p plus 4 inside a parenthesis. So it does make sense if we take a minus 1 out. Negative 1 times p is negative p. Negative 1 times 4 is negative 4. And in the next step, just like we did on this one, you can imagine this to be one single variable. So it's like saying 2p times a, all of this is a, p plus 4, minus 1 times a, p plus 4, and therefore you can take the a out, which is p plus 4, we are going to replace that soon, times 2p minus 1, which is equal to, replace the a back, p plus 4 times 2p minus 1. That is the factored form or the factorized form of 2p squared plus 7p minus 4.